Machiel. I'm Daniel, still taking you in O-level chemistry for TEP Talks. We are going to look at calculations of relative formula mass. Calculation of relative formula, or what we call relative molecular mass. So last time we looked at what we call relative formula mass. We said that in the actual sense it is a ratio or a quotient relationship whereby we have relative formula mass, let me call it RFM, being equal to the ratio of the mass of 1 mole of atoms of an element to 1/12 of the mass of 1 mole of carbon 12 atoms. So this expression gives us what we call the relative formula mass or the relative molecular mass of a compound. In this case, we are dealing with compound, not an element, of a compound. So it is the ratio of the mass of 1 mole of atoms, let me call it particles, of a compound to 1/12 of the mass of 1 mole of carbon 12 atoms. So we say that if we are to substitute for this and work it out, we shall find that we get a value which has got no unit completely. It's not in grams. So relative in this case means that there is a relationship of between two similar items with the same unit, and in this case the units cancel and you remain with just the values. So that is it. Now in the calculation of relative formula mass, we shall not be using this expression. Instead, we shall be using the values of the relative atomic masses of the elements which are found in 1 mole of that compound. We shall be adding the relative atomic masses of those elements. So let us take, for example, carbon dioxide. If I take carbon dioxide, the first thing that you need to do is to work out the formula mass of the compound so that you see the number of atoms of each element in one particle of that compound. So in carbon dioxide, we have carbon and oxygen, which are the elements in it. Now, carbon, we know that the valency of carbon is 4, since in this case, the valency of carbon is 4 because the atomic number of carbon is 12, the electronic configuration is 2, the atomic number is 6, the electronic configuration is 2 to 4, and if you want to get the valency of carbon, it is 8 minus 4, as we had seen the other day. So you find that the valency of carbon is 4, the valency of oxygen with atomic number 8 and electronic configuration 2 to 8, the valency is 2. So when they exchange valencies, these two come here, this 4 comes here, and when we reduce by 2, since 2 and 4 are both multiples of 2, this one becomes 1 and this one becomes 2. So this one is the correct formula of carbon dioxide gas. Now what we are going to do is we are going to add the relative atomic masses of these elements here together to give us the relative molecular mass of carbon dioxide. We shall be given, or the relative atomic masses of these elements are given, that the relative atomic mass of carbon is 12, the relative atomic mass of oxygen is 16. So we shall add these ones here together. You must count the number of atoms carefully. So you will now multiply the number of atoms of each element by the relative atomic mass of that element. So in getting the relative formula mass or the relative molecular mass of carbon dioxide, we have only one atom of carbon, and one atom of carbon has got a relative atomic mass of 12. So this one will be 12, of course it is 12 times 1 plus, oxygen atoms are 2, but we know that the relative atomic mass of oxygen is 16. So it will be 16 times the 2 atoms of oxygen. So this one gives us 12 plus 16 times 2 is 32, and the total will be 44. And this is the relative molecular mass of carbon dioxide. This is just but one example. Let's look at another one. Let's look at sodium oxide. Sodium oxide. So in sodium oxide we have got sodium and we have got oxygen. Now, the valency of sodium is 1. Since the atomic number of sodium is 11, configuration 2 to 8 to 1, the valency of sodium is 1. Oxygen has got atomic number 8. The electron configuration is 2 to 6, and the valency is 8 minus 6, which is 2. So this 2 comes here, we put it here, and this one goes there. Of course, we are seeing one oxygen atom, and this is the formula of sodium oxide. Now, let us work out the relative formula mass of sodium oxide. It is going to be, we shall be always be given the relative atomic mass of sodium is 23 and oxygen is 16. So, in sodium oxide, we have 2 atoms of sodium. We shall multiply it by the relative atomic mass of sodium, which is 23. So, it will be 23 times 2. And we add it to, remember we are going term by term. That is element by element. We first finish an element, then we go to the next one. So oxygen, we have only one atom of oxygen, and the relative atomic mass of oxygen is 16. So it will be plus 16. And then we add this together. This one becomes 46 plus 16. And this one gives us a total of 62. That is the relative formula mass of sodium oxide. Let us look at other examples still of compounds, and we see how to get their relative formula masses or relative atomic masses. Now let us look at a compound like lead 2 nitrate. Lead 2 nitrate. So in lead 2 nitrate we have got lead metal, and we have got a radical in lead 2 nitrate, that is the nitrate radical, with a formula of NO3. Now let me put for us here the valencies of the radicals, because they are supposed to combine. So we need to have the valencies or the combining powers of these radicals. I have sulfate, which is SO4. The valency is 2. There is nitrate, whose valency is 1. There is carbonate, whose valency is 2. We have got phosphate, PO4, whose valency is 3. We have got hydrogen sulfate, whose valency is 1. There is hydrogen carbonate, whose valency is also 1. There is an important one which is always very common, that is the hydroxide radical. This one also, the valency is 1. We have got ammonium radical, NH4. The valency is also 1. We have got hydrogen phosphate. This one, the valency is 2. Then we have dihydrogen phosphate, the valency is 1. So we shall be using the valencies of these radicals in finding out the formula of a compound in which the radical is. So let us look at lead to nitrate. The valency of lead in lead to nitrate. What you are seeing in the bracket is the valency of this metal. So lead in this case has a valency of 2 and nitrate has got a valency of 1. So this 1 will come here and this 2 will go there. So where we have the base number being more than 1, that is from 2 onwards, we are supposed to put that radical in a bracket and place the base number outside the bracket here. So this is the formula of lead to nitrate. Now let us get the relative formula mass of lead to nitrate. So lead has got a relative atomic mass of 207. Nitrogen is also an element in lead to nitrate. The relative atomic mass is 14. Oxygen has also a relative atomic mass of 16. So let us add these relative atomic masses of the elements together to give us the relative formula mass of lead to nitrate, not forgetting the number of atoms of each element. So we are starting with the lead. Remember, you need to go systematically, term by term, element by element. So we are starting with the lead. The relative atomic mass is 207 and there is only 1 atom of lead. We are adding it to, let's go to nitrogen. You should be having the ability to count the number of atoms well. When you see a bracket and there is a number outside the bracket, that number outside the bracket multiplies the number of atoms of each element in the bracket by itself. So in this case, we shall multiply the number of nitrogen atoms inside here by 2. So we have got 2 atoms of nitrogen, but each atom of nitrogen has got a relative atomic mass of 14. So it will be 14 times 2, and we still add it to oxygen atoms. We are seeing that we have got 3 times 2 oxygen atoms, and oxygen has got a relative atomic mass of 16. So it will be 16 times 3 times 2. So let us get this. This one becomes 207 plus 28 plus 16 times 3 is 48 times 2 is 96. If we add these ones here together, we shall get a total of 331. So this one becomes the relative formula mass of lead to nitrate. Now, let us look at one which is also there, simple. Let us look at, say, calcium phosphate. So let us firstly get the formula of calcium phosphate. Calcium phosphate, in it we have got calcium as an element. Then we have the radical phosphate. And in this case, we can see that the valency of calcium, since the atomic number of calcium is 20, the electronic configuration is 2 to 8 to 8 to 2, giving us a total of 20 electrons. So in this case, the valency of calcium therefore is 2. A phosphate radical, from here we can see that the valency is 3. So we are supposed to exchange these valencies here. So this 3 comes down here. And then these 2 must go there. So when these 2 crosses here, 2 is more than 1. So we shall have to put this phosphate in a bracket and put 2 outside the bracket. And this is the formula of calcium phosphate. Now, calcium as an element has got a relative atomic mass of 40. Phosphorus has a relative atomic mass of 31. Oxygen with a relative atomic mass of 16. And then let us now get the relative formula mass of calcium phosphate using the relative atomic masses of the constituent elements. So here, calcium has got 3 atoms, and each atom of calcium has a relative atomic mass of 40. So it becomes 40 times 3. We add it to, we come to this. The phosphate is in a bracket and 2 is outside the bracket. So there are 2 atoms of phosphorus. So it will be 31 times 2 plus oxygen 16. It will be 16 times 4 times 2. So let us see what we get. 40 times 3 is 120 plus 31 times 2 gives us a total of 62 plus 16 times 4 is, in this case it is 64. 64 times 2 is 128. 128. Then we have to add these ones here together. This 130 plus 60 is 190 plus 20 is 210. Then plus 100 is 310. Let us prove using a calculator. 120 plus 62 plus 128 gives us exactly 310. So this one is the relative formula mass of calcium phosphate. Now, in your free time, you need to try for me this. We need to try the following. This is an assignment. Calculate the relative formula if it is an ionic compound or relative molecular mass of each of the following